Okay, welcome to the this video. It's a video on me working through the adventures in less basic derivatives, something. I forget the title, but anyway, hopefully you're making good progress studying for the test on Monday. And remember to send me an email or something if you have some questions. And so anyway, here we go. So this first one, A, says take the derivative of f times g, but then evaluate it at 1. So that would be f prime of 1 times g of 1 plus f of 1 times g prime of 1. So then we just go up to the table and plug in the right things. So for f prime of 1, that's 2. G of 1, so there's my 2. G of 1, that's 1. F of 1, that would be 1. And G prime of 1, that would be 0. So of course in the end it'd just be 2. Okay, same idea over here. F prime of f divided by g, and you're taking the derivative and it's evaluated at 5. So first of all, that's going to be equal to low d high minus high d low. And that's all over low squared. So once again, we go up to the 5 row. Now we're looking at this row right here, right? Because we're plugging in 5 everywhere. So g of 5 is 2. F prime of 5 is 3. F of 5 is 1. And g prime of 5 is 5. Of course, that's all over g of 5, which is 2 squared, which would be 4. So I end up with 6 minus 5 over 4, or 1/4. Okay? Still using the tables from above for f and g, find dy dx for the following. So dy dx, we're going to have to use the product rule here. That's going to be derivative of x squared, which would be 2x times f of x, plus x squared times f prime of x. Whoops, I forgot to give you a number. So let's say we're evaluating all of these for x equals 3. So of course, that's what it would look like without a number, but once we evaluate a number, so like in other words, dy dx, x equals 3. So that would mean plug in a 3 everywhere you see an x. So that would be 2 times 3 times f of 3, which is 3, plus 3 squared, which would be 9, times f prime of 3, which is also 3. Whoops, I messed it up. F of 3. Oh no, f prime of 3 is 5. So that would be 5. So that would be 2 times 9 is 18. 18 plus 45 is 50, 63. So again, the way the directions stand, you would just stop here. I forgot to put a little where to evaluate it. So this is not that interesting because you don't actually use a table. But what I meant to do is have this little x equals 3 out here. So I'm evaluating each one at x equals 3. That's what would drive me to the table, to fill in that value and that value. Okay, so anyway, let's do this. So dy dx, I'll make a little room over here. So dy dx is going to be equal to x squared times g prime of x minus g of x times 2x, because that's the derivative of the bottom, all over x to the 4th. And again, you could plug 3 in there if we wanted to know what dy dx evaluated at 3 is. That would be 9 times, and g prime of 3 is right there. It's 2. 9 times 2 minus g of 3 is right there, also 2. And then 2 times 3 would be 6. All over 3 to the 4th, which would be 81. So that'd be 18 minus 12, which would be 6 over 81, which would reduce to 2 over 27. Okay, so this one is another quotient rule. So dy dx is going to be equal to low d high, which would be 2x, minus high d low all over low squared. And then you could plug 3 in everywhere again. I'm going to move on from that one. This one's kind of a unique one. So what is dy dx? Well, low is square root of x. D high. Now what's the derivative of high? That would be, the derivative of 4 is 0, so that disappears. And this would be a product rule, wouldn't it? So it'd have to be square root of x times the derivative of x, which is 1. So that'd be times f of x plus x times the derivative of f of x. So that'd just be the first layer, or the first part of the top, minus from that. So the square root of 1/2, or the square root of, I'm sorry, the derivative of square root of x, that would be 1/2 x to the negative 1/2 times 4 plus x f of x all over square root of x squared, just be x. And then again, if I wanted to evaluate that at 3, that'd be dy dx, evaluated x equals 3. So that'd be the square root of 3 times f of 3 is 3. 3 plus 3 times f prime of 3 is 5 minus 1/2. So that'd be 1 over, whoops, sorry. No, that's down there. This would be 1 over 2 times the square root of 3 times 4 plus 3 times f of 3, which is 3. I think I'd remember that. I've seen that several times now. And on the bottom, I just have 3. So then you could simplify that. That's going to be what, 15 plus 3 is 18, so that'd be 18 times the square root of 3 minus 4 plus 9 is 13, so that'd be 13 over 2 rad 3 all over 3. So I think I just multiplied by 1/3. So that would be 6 rad 3 minus 13 over 6 rad 3. And that would be my final answer. Okay. So moving right along here, now we're just asked to find the derivative of the following. So first thing I would do before I found the derivative is I turn this into, okay, so I'm going to rewrite this sine of to the 4th power of 3x times, now tangent is sine over cosine, and it's being divided. So that means I'd flip it over and multiply. So it'd be cosine squared 3x over sine, come on, sine squared 3x. And of course, 2 of the sines are going to cancel with 2 of those sines. So I'm left with, this is still f of x, I haven't taken the derivative. That would be sine squared of 3x times cosine squared of 3x. So then I can just use the product rule. So that's going to be f prime of x is equal to 2 sine of 3x times the derivative of sine, which would be cosine of 3x, times 3. So I'm just going to make that a 6, times cosine squared. So that's the first part of the product rule. Then I'm going to add to that sine squared of 3x times the derivative of cosine squared, which would be 2 cosine 3x times the derivative of cosine, which would be negative sine 3x times 3. So then if I simplify all that, I get 6 sine 3x times cosine to the third 3x plus, no, actually minus 6 sine cubed 3x times cosine 3x. It's not too bad. But this one I'm going to make a little room over here to the side. So let's start out with, by rewriting it, that would be f of x is equal to, I would change this 4 square root raised to the 4th power is really just the 2nd power. So that would just be 2 ln times, or ln of sine cubed x over cosine squared x. And if those two powers are the same, I might pull them out, but since they're different, I think I'll just leave them. Let's see, So actually, let me think about this. So this is actually going to be squared now because the 4th square root to the 4th power is squared. So I could rewrite this as the natural log of yeah, no, there's not a clean way to write it. So, okay, so anyway, I'll just write this as 2 ln of sine cubed x over cosine squared x. Okay? Now I'm ready to take the derivative. So f prime of x is equal to, the 2 just goes along for a ride. The derivative of ln just means I take the reciprocal of the thing inside. So that's going to be cosine squared on top and sine cubed on the bottom. And then I have to take the derivative of sine cubed over cosine squared. So this is going to be a big quotient rule here. So that's going to be low d high, which would be 3 sine squared x cosine x minus high sine cubed x times the derivative of low, which would be 2 cosine x times negative sine x. All that's going to be over cosine to the 4th. And of course, like what normally happens when I'm taking when I have a natural log with a fraction inside, some things cancel out. So I'm going to rewrite this as f prime of x is equal to, that 2 is still going to be sitting out here on top. And those cosine squares can cancel out completely. So on the bottom, I'm going to have sine cubed x times cosine squared. I'll just write that so I don't forget it. Then on the inside here, I'm going to have what? Cosine to the 3rd x and sine squared. And that 3 will multiply by the 2 to give me a 6. Then I have that minus and that minus are going to turn this into a plus. And that 2 and that 2 will make this a 4. So then I end up with sine to the 4th power times cosine. And then I realize that there's a factor of sine and cosine in the top and bottom, maybe even more than one. So I can factor out 1 cosine from the top. So that would leave me with 6. 1 cosine from the top and 2 sine from the top. So that would leave me with 6 cosine squared sine plus 4 no, not even sine. I said 2 sines, didn't I? Yeah. So 6 cosine squared plus 4 sine squared. That's all that's left on top. And since I factored out 2 signs from the top, that leaves only 1 sign in the bottom. And since I factored out 1 cosine from the top, that leaves only 1 cosine on the bottom. And that would be my simplified derivative. Okay. So coming back here to the main thing, this is another one of those that's just strung out so you can see, test a couple different things at once. So let's just do it. It's probably ready to take the derivative right now. I don't think I need to do any algebra. Yeah. Actually, I could do this. This is kind of a nifty little maneuver. I could turn this into x times log base 3 of e. Isn't that cute? Because the exponent can come out front. That's the power of that's the beauty of log rules. So that turns into just a linear equation, doesn't it? Whew, I didn't even notice that when I wrote this. Okay, so f prime. So first of all, this is going to be the natural log of 3 times 3 to the cosecant of 4x times the derivative of cosecant of 4x, which would be, ugly parenthesis, derivative of cosecant is negative cosecant of 4x times cotangent of 4x times 4. So that's the first part. This one is going to be just log base 3 of e, because that's just a number, and it's a number times x, so the derivative of a number times x is just the number. And then finally, the derivative of secant of e to the x, that would be secant of e to the x times tangent of e to the x times e to the x. And let's see, can we simplify this some? Maybe a little bit. This will just be natural log of 3 times 3 to the cosecant of 4x. And that will have I guess I could put a negative 4 out front here because of that negative and that 4. And then I'd have down here cosecant of 4x times cotangent of 4x. And this is just going to be natural log of log base 3 of e, whatever that is. And then there's no real way to rewrite that, so that'll just be, maybe I'll put the e to the x up front, but then it'll be secant of e to the x and tangent of e to the x. So that's kind of cool. Okay, number D. We got 3 parts here, 3 multiplications, and they're all got powers, so I'm probably going to just start by rewriting. So we'll go out here, f of x equals, x squared minus 1 to the 4/3 power. X squared minus 1 to the 4/3 power times x squared plus, I said x squared plus 1 to the 3rd power and 3x cubed. Okay. So here's this is a unique one. I don't think we've done one like this before. So you have it's a 3-part multiplication, which would use the product rule, but you can't. There's no product rule for 3 parts. So what you have to do is, for example, you could call this u, and you can call this whole thing v. So then if I go over the side here, what's u prime? Well, that's 4/3 times x squared minus 1 to the 1/3 power times the derivative of x squared minus 1, which would be 2x. So u prime is going to be 8x over 3 times x squared minus 1 to the 1/3 power. Now, v prime, I'm going to have to use the product rule again, Well, I haven't used it yet, but I'm going to use it for the big one. But v prime is going to require the product rule because I have something times something both involved in a x. So v prime is going to be 3 times x squared plus 1 times 2x. That's the derivative of this first part. Whoops, there's a squared there. Times 3x cubed plus x squared plus 1 to the third power times the derivative of 3x squared, which would just be 9x. I'm sorry, derivative of 3x cubed, which would be 9x squared. And we can simplify that a little bit. That would be what? 2 times 3 times 3 is 9 times 2. That'd be 18x to the fourth times x squared plus 1 squared plus 9x squared times x squared plus 1 to the third. So I think I would do that first. I have my u prime and my v prime. Now I'm just going to plug into the product rule back over here at the original guy. So to find f prime of x, that's going to be u prime v plus v prime u. And that's going to just bring all these things I just did in here. So what is u prime? We said that that's, I'll make this a little bit smaller. That's 8x over 3 times x squared minus 1 to the 1/3 times v, which is x squared plus 1 to the third times 3x cubed, because that's what I called v. Okay, then over here, I'm going to need v prime, which, and I'll put a big parenthesis around that. That'd be 18x to the fourth times x squared plus 1 squared plus 9x squared times x squared plus 1 cubed. That's my v prime. I have to multiply that by u, which would be x squared minus 1 to the 4/3 power. Pretty slick. So then I just got to simplify a little bit. So I'm going to have, I can definitely multiply the 8x over 3 and the 3x cubed together. So that would give me, the 3's will cancel out. That'll give me 8x to the fourth. And then times x squared minus 1 to the 1/3 and x squared plus 1 to the third. And that'd be my first term. My second term, I'm going to distribute this through there. So that would be 18x to the fourth times x squared plus 1 squared times x squared minus 1 to the 4/3 power. And then my third term, we'd be multiplying this times that. So that'd be 9x squared times x squared plus 1 to the third times x squared minus 1 to the 4/3. I think that takes care of everything. Oh, this thing goes on forever. This thing's getting kind of long, so I think I'll stop it for now and then maybe pick up later in a minute. Or just make a new video.